Imagine waking up one morning to find the world around you has fallen into a terrifying silence. No more murmuring rivers, no more rhythmic crashing of ocean waves, even the sound of water dripping from your shower has vanished. You step outside, and what greets you is a reality so cold it makes your skin crawl. The deep blue oceans we once knew have become massive blocks of white concrete, rigid and soulless. Everything has ground to a halt. Life, which used to be so bustling and noisy, is now nothing more than a lonely sigh in a colossal frozen graveyard. And all of this horror happened for one reason only. Water decided to end its rebellion. Water decided to become obedient. Sounds strange, doesn't it? We've always been taught that this universe operates on ironclad, unchangeable laws of physics. Every piece of matter must comply, from the distant stars to the sand beneath your feet. But there is a villain, or rather, a stubbornly defiant rebel, that has been silently breaking every single rule for billions of years. It's the very thing sitting in the glass on your table, the thing that makes up 70% of your body. Water. Water doesn't care about the laws. Water refuses to obey. Water is freakishly rebellious, and that rebellion is the only reason you and I are still here to talk. But what would happen if that grand system error was suddenly fixed? What if water stopped shattering rules and started behaving like a normal, exemplary, and proper liquid? Have you ever wondered why, in such a harsh universe, we were lucky enough to be born thanks to a rebel? Take a close look at that frozen world out there. That isn't a sci-fi movie. That is the true face of physics without water's interference. A profoundly wrong vision. A colossally unsettling reality. Brace yourself, because we are about to enter the craziest journey yet. Discovering how fragile human existence truly is on the knife edge of a chemical bond, and what happens when water decides it's no longer going to be itself. Imagine an alien chemist in a distant spacecraft, peering at our Earth through a telescope. After running a few basic thermodynamic calculations, he'd breathe a sigh of relief, close his notebook, and confidently tell his crew, "Don't worry, that blue planet is just a dead rock, zero chance for life." Why so certain? Because according to every physical law the universe has ever established, Earth should be a permanent block of ice, cold and solid from the ocean floor to the surface. He wasn't wrong. Physics wasn't wrong. Only water was wrong. In the world of the obedient, everything follows one ultimate rule. Heat expands. Cold contracts. You heat an iron bar, it grows longer. You cool a block of lead, it shrinks and becomes denser. Almost every substance in this universe, from ammonia to methanol, obeys that command absolutely. And when they transition from liquid to solid, molecules huddle closer, density increases, and as a result, they sink. That is how the universe works. But the moment the cold hits the 4 degrees Celsius mark, water looks at that rulebook and says, "Not me." Instead of contracting, water begins to expand. Instead of becoming heavy, it suddenly becomes light. A freakishly high paradox, a colossally disagreement with the rest of nature. But think about the price of obedience. If water followed the rules like every other liquid, the catastrophe would begin in the darkest place, the ocean floor. When winter strikes, those first ice crystals forming on the surface would no longer float like lifebuoys. They would be as heavy as lead stones and plunge straight into the abyss. Down there, where sunlight never reaches, they would accumulate. Day after day, year after year, the seabed would no longer be warm silt, but a thick, frigid layer of ice that never melts. The sun's heat could only lick the thin layer of water on the surface, while the darkness and freezing cold below silently swallowed the entire planet. The oceans would freeze from the bottom up, turning into a giant crystal coffin. That vision is truly unsettling. The entire ecosystem as we know it would be strangled. The warm currents that nourish the continents would vanish, replaced by a deathly silence. Life, which began in the ocean, would be caught between two pincers. The sun scorching the thin surface water on one side, and the permanent ice rising from below on the other. No escape, no evolution. Earth would become a literal snowball, a blank white marble drifting aimlessly through space. We only exist today because water refused to be a good student. Its defiance created a shield of floating ice, keeping a whole aquatic world warm underneath, preventing the white death from rising from the depths. But why? Why does such a simple molecule dare to disobey the entire universe? The answer doesn't lie in what we see, but deep within the invisible handshakes at the molecular level. So, what created this grand defiance? Why does water dare to reject every physical law to keep us alive? To understand that, we must leave the macro world of giant ice blocks and dive deep into a strange ballroom at the molecular level. There, a quantum-level action script is unfolding in every trillionth of a second. Imagine water molecules like guests at a vibrant dance party, but instead of just gliding past each other, they have a very peculiar habit. They hold hands, unbelievably tight. This is the hydrogen bond, an invisible handshake so powerful it turns the universe upside down. Look at these telling numbers. They will blow your mind. If water behaved like a normal chemical compound, like its cousins hydrogen sulfide or hydrogen selenide, its boiling point wouldn't be 100 degrees Celsius. Water should have boiled and turned into gas at 80 degrees Celsius. You heard that right, minus 80 degrees. That means right now, all the oceans, all the blood in your veins, and even your tears should have completely evaporated into space long ago. Earth wouldn't be a blue planet, but a dry, deadly ball of gas. But water said, no. The handshakes of the hydrogen bond are so persistent that they require a massive amount of energy to break. It turns water into a great heat absorber, a giant warm towel wrapping around the planet, keeping your body temperature stable at 37 degrees Celsius, whether it's a blizzard or a desert fire outside. The truth is, we exist thanks to a colossally freakish system error of nature. Science calls them water anomalies, but I prefer to call it a miracle disguised in chemical clothing. From surface tension that allows sap to climb to the tops of the tallest trees, to the specific heat capacity that keeps Earth's climate from becoming an inferno, it all comes back to those stubborn handshakes. Even supernatural phenomena like the Mpemba effect, where hot water freezes faster than cold water, or proton tunneling in quantum mechanics, all show that water isn't just H2O. It is an entity challenging every limit of human understanding. We don't survive because of the perfection of physical laws. We survive because of the greatest glitch in the universe. Look at this last drop of water clinging to my finger. It's so small, so still, and seems so harmless. But after everything we've just been through, do you still see it as ordinary? This drop is a constant reminder of how fragile we all are. Humanity doesn't stand on a foundation as solid as we like to think. In fact, we are dancing on the extremely sharp edge of hydrogen bonds. In just a split second, if these molecules decided to stop rebelling and rigidly follow physical constants, our entire civilization, our dreams, and even your very breath would vanish like a mirage. The universe is inherently a harsh place full of cold, unyielding laws. Yet, in some miraculous way, it has granted us an unthinkable favor. It allowed the simplest, most common liquid the right to break every rule to protect life. Hey, every time you lift a glass and take a deep drink, it's not just about quenching your thirst. It's the moment you take into your body a piece of a miracle, a confirmation that we still have a chance to exist. Your existence is a privilege built on the stubbornness of water. So, take a moment to feel grateful. Grateful for the great system error that kept the oceans from freezing, kept our blood from evaporating, and kept this earth forever a hopeful shade of blue. But let me leave you with one final question, one that might make you ponder every time you see rain falling or waves crashing. We always pride ourselves on our intelligence, our technology, and our human power to conquer nature. But what if one day, for a reason science has yet to grasp, water simply grows tired of this billion-year rebellion. If it decides to become obedient, to become exemplary and submit to physics like every other matter, then in that moment, who are we? And will there be anyone left to tell the story of the universe's greatest rebel?